For being late. Had a conversation with a team member here. Okay, so let's get into today's lecture. Today it's mostly just gonna be watching videos. I do have a few comments here and there, but largely today is gonna be the lecture for a crash course of JavaScript or client-side JavaScript, or some may call it front-end JavaScript. And I don't actually expect any of you, if you don't have previous experience with JavaScript, to just by taking watching this lecture become a JavaScript pro. It's really also it touches many different aspects of JavaScript. You don't necessarily need to do anything hands-on with JavaScript in this course. So so today's lecture is more of just give you a preview of what's going on with JavaScript, and then a few like pitfalls, things to be aware of, some good overview of JavaScript, and then in terms of its role in a SaaS application or web application. And then we won't have any assignment or homework. At least I don't think so, and I don't have anything planned for JavaScript. So just take it easy. Just enjoy this 2 hour watching the video, and hopefully it can give you a good understanding of what's going on with client-side JavaScript, and we will touch on something like although these days people are super excited about JavaScript, running it both on front end and back end, or server side and client side, and then there are a few arguments to be made there. And again, it's more of a personal opinion, and I do have my opinion on that thing. But again, feel free to have your own opinion, but try to make some informed decision when you think about if you want to go about JavaScript on the server side or not. Ideally, when you get chance, experiment with it. Use different languages and different framework for some similar application, especially for backend, and see how you would feel. Which one you feel better using in future projects. So okay, with that being said, we will get straight into the videos. So all the videos today are taken from the advanced, or the part 2 of that Berkeley course, and that's part 2, module 2, SaaS clients, and that's basically JavaScript. So for this module, the total duration of all these videos actually exceeds 2 hours. So today we won't be able to finish everything here. Of course, we will be able to finish the most important videos in this module. And then after today, we're basically done with JavaScript. So there will be videos that we won't be able to finish today. And then ideally, if you get time to spare, your spare time, finish the remaining videos. If not, it's actually also fine, because the ones that we're not going to be able to finish, that's are less important. So that will be also fine. Right, so without further ado, let's get into the video.
The invention of the web dates to 1990, when physicist Tim Berners-Lee at the CERN Particle Accelerator in Switzerland created a set of technologies to allow combining text, graphics, and most importantly, hyperlinks within the same document. The idea for doing this using modern technology had been around since at least 1943, originally outlined in a now famous article called As We May Think, written by Vannevar Bush, an electrical engineer and scientific advisor to the US government during World War II. But it wasn't until decades later that computing technology was mature enough to implement those ideas in a way that could have wide impact. The software developed by Tim Berners-Lee and his colleagues was revolutionary, and in 2016, he received the Turing Award in recognition of his pioneering work. But for the first few years, the World Wide Web, as he called it, was practically unknown outside the academic and scientific communities. In 1993, though, a group of programmers at the University of Illinois created Mosaic, the first graphical web browser that non-experts could easily install and use on consumer PCs. Within a year, Netscape Communications had been founded as a startup to commercialize the browser, and Netscape quickly became the most important company in making the web a mass-market phenomenon. In 1995, PC users thought it was pretty revolutionary to seamlessly combine text and graphics on the same page and to follow hyperlinks to related pages anywhere on the web. But early web pages were pretty boring by today's standards. Text, graphics, and fill-in forms were about all you got. So Netscape decided to change all that by providing a way to write code that could manipulate content on a page after the browser had loaded it, allowing pages to include much richer interactive elements. But what language would they choose for providing this capability? Brendan Eich, the creator of JavaScript, initially wanted to use Scheme, a dialect of the venerable Lisp programming language, because of its elegance. On the other hand, Netscape had just solidified a business relationship with Sun Microsystems to promote its new Java programming language, so Eich was being pressured to use Java as the browser's language instead. In the end, Eich and Netscape founder Marc Andreessen, along with legendary Sun Microsystems software engineer Bill Joy, agreed that the browser needed a language that was more approachable by beginners, analogous to why the BASIC programming language had been invented in 1964. There was only one problem. The so-called browser wars between Netscape and Microsoft were heating up, and Netscape wanted to release their new in-browser programming language with the next release of their browser, which gave Brendan Eich just 10 days to design and implement the core of JavaScript. As you can imagine, such a hurried design means that the language is not without problems. But it's remarkable how quickly it grew from a language designed to enhance static web pages to a language that could create single-page apps like Google Docs using AJAX, or Asynchronous JavaScript and XML, a technology first introduced in Microsoft Internet Explorer. In this module, you'll learn about the special relationship between JavaScript and the browser, and you'll approach JavaScript, the jQuery framework, and AJAX using the same strategies we used earlier to learn Ruby and Rails. Just as Rails takes advantage of specific Ruby features, JavaScript's asynchronous programming model, in which an app can initiate a long-running operation and specify a callback function to be invoked later when the operation completes, is a great match for creating an interactive user experience in a web browser. Along the way, you'll encounter some of the tools and techniques that developers have created to manage the complexity of today's JavaScript apps, including how to test both JavaScript-based user interfaces and AJAX functionality. While new JavaScript frameworks seem to appear every few months, if you understand the basic ideas of how JavaScript interacts with the browser and how its asynchronous, event-based programming model works, you'll be in a good position to learn any new framework rapidly, And that's what keeps great software engineers in demand.
All right, that's the quick overview. Next, I believe we'll get into some more history, and some of the history is pretty interesting regarding JavaScript. Let's get into the next video.
This is Brendan Eich. He's the creator of JavaScript, and the original version of JavaScript was done in something like a couple of weeks. It was insane. So let's, before diving into the language, let's talk a little about how we got to be this way. First, just to put some of my own biases on the table, so you know which things are just my opinion and which things are widely accepted. I think JavaScript has a bad reputation that is not entirely deserved. It has some flaws in its design, but I think all languages have some flaws in their design. So using JavaScript tastefully is actually just fine. I think the reason it has such a bad rep and the reason that I tend to bristle about it is because most JavaScript code that is out there is awful, just awful. It's like the work of programmers who don't understand objects or encapsulation or anything. It's cut and pasted from a million different websites, and probably a lot of it, the people who authored it have no idea how it works. You are all seasoned programmers, so you won't have this problem. I also believe that as much as possible, using JavaScript should be a way to enhance the app, but the lack of JavaScript shouldn't kill it. Now, granted, there are certain types of interactions that the only reasonable way to do them at all is by using JavaScript. But, for example, if your web app has a fill-in form, and the fill-in form doesn't have any special elements on it that, other than the usual drop-downs and text fields and stuff, on a page like that, not having JavaScript should not make the page unusable. There's no reason that a page that otherwise would have worked just fine without JavaScript all of a sudden breaks if JavaScript is not present. And one reason for that is, as we're going to see, there's a lot that you can do to ensure that your JavaScript works on a variety of different browsers, different OSs, and stuff like that. But getting to 100% confidence on that can be really challenging. So you have to assume that once in a while, your JavaScript code will fail on someone's browser in a way that you didn't anticipate. And your goal is to minimize the likelihood that that results in your website becoming unusable. Maybe it becomes a little less convenient to use or less whizzy or something. But as much as possible, don't rely on it as a crutch unless you absolutely have to. In terms of an app, if we think primarily about apps that are server-heavy, server-focused, and they are primarily serving a web-based UI to the user, my opinion is that in those apps, something like jQuery is the place to start. So what do I mean by that? First of all, don't do anything that relies on just the native JavaScript bindings without something like jQuery. Because if nothing else, jQuery gives you compatibility across a range of platforms. It gives you some nice higher order behaviors that are not built into the browser's implementation of JavaScript but are super convenient to have. There's been a big movement recently to using essentially full stack frameworks like React or AngularJS for so-called single page apps. We won't talk much about that in particular. I will go as far as to say that as with all tools, you should use the simplest framework or libraries that will serve the needs of your app. So when we started out talking about software as a service server side, we introduced Sinatra as a much, much simpler framework than Rails for building server-side apps. And if you have an app in mind that could have been built with Sinatra, you should build it with Sinatra or something even simpler. Similarly, if you have an app that can mostly be built in HTML5, but with some enhancements that make use of JavaScript in tasteful ways, I think that you need a reason to use a full-blown framework rather than a reason not to use one. They add more complexity, they add testing complexity, they add some maintenance complexity. So if you're going to buy into one, just make sure that it legitimately solves a problem you have, as opposed to it's because I need an excuse to learn the framework. And just as I think TDD is extremely important for actually having self-checking tests for your server, you can do that in JavaScript as well. It is much more painful, but there are tools like Jasmine that help. And a lot of the same techniques that you already know how to stub the results of calls and return a controlled thing, how to build doubles of objects that have certain canned behaviors so you can control code paths. JavaScript, the language, allows you to do all those things. And Jasmine, the framework, allows you to actually do the testing techniques just as RSpec does for Ruby. So although we won't get to it today, either Tuesday or Thursday of next week, we'll show some examples of how you would rigorously test client-side JavaScript code using Jasmine. As far as I'm concerned, I'm still sort of a skeptic about server-side JavaScript for reasons that I hope will become clear between now and next week. I'm open to being convinced otherwise. Somebody has said, you know, if you looked at Express.js, you would change your mind. I haven't looked at it yet. I'm open to changing my mind. Probably I won't get around to doing that till after the semester's over. So for now, you're going to have to deal with my cantankerous point of view on this. OK, so a little bit of JavaScript history. Where did it come from? It's actually older than most people think. In 1995, Netscape had taken over the world. They were the darling of all startups. They were like the original unicorn. And they wanted to have a simple language that could be used to enhance client-side pages. What they had in mind was stuff like, you know, animating simple things on the page or being able to check input forms before they get submitted to the server. And they came up originally with the name LiveScript, but they decided to change it to JavaScript. Anybody have any idea why? Or want to guess why? You can be cynical. Did you raise a hand or did you, what do you think? To ride the hype of Java. That is exactly correct. This was around the time that Java was going to save the world because it was write once, run anywhere. At the risk of being snarky, I think it's become write once, run nowhere. But Java was super popular. Everybody thought that Java was going to be the language, it's going to take over the world. For a long time, a lot of classes here were taught in Java. I know some of them still are, but we're recovering from that. But nonetheless, Java was big. So like, all right, well, let's call it JavaScript. The only thing that JavaScript and Java have in common is those 4 letters. As languages, they're way more different than they are alike. In fact, JavaScript is much more like Ruby than it is like Java, but back to that later. The browser already had the idea of a document object model. This is basically the internal representation of how the document is represented, and it is used by the browser to lay out the document on the screen, to track the user's interactions with different things on the page. So the idea was whatever this embedded language was going to be, that language would have bindings, right? There would be a representation of the DOM that was available in that language. And if you modified that in-memory representation, it would have the side effect of changing what was displayed on the page. And conversely, you could inspect that in-memory representation to learn things about what was being displayed on the page. In 1997, JavaScript was standardized as ECMAScript, which sounds more like a skin disease than a language. But whatever. Officially, JavaScript is a variant of the standard. The standard is this. So, and I can't remember which other variants there were, but Microsoft had one for a while called JScript, which was another variant. But the real important thing happened after that, which is when Microsoft added something to Internet Explorer 5. Yes, Microsoft was the first browser to do this. They added a new Java visible function called XML HTTP request that did this revolutionary thing, which was it allowed a web page that had already been loaded to make an HTTP request to the server that did not necessarily result in redrawing the page. That's all it did. It separated the act of doing an HTTP request from the act of rendering an HTTP response. And in particular, the response would eventually arrive later, and JavaScript would be handed the response and would be allowed to modify the DOM model and change what was on the page in reaction to that. So that's really what made the so-called Web 2.0 apps possible. Google Maps appeared in 2005 and kind of showed people what you could really do with JavaScript if you, were clever. And AJAX became a thing, which is asynchronous JavaScript and XML. So called because today there is not any XML to be found anywhere. It's all, now it should be like AJAJ, asynchronous JavaScript and JSON. But we'll get back to that next week too. In 2015, the 6th major revision to the ECMAScript standard was introduced, and it is a major revision, major. It fundamentally changes some of the programming abstractions in the language. So everything we say from this point on about JavaScript is conditioned on this major, major caveat that JavaScript is continuing to evolve very, very rapidly. ECMAScript v6 adds things like classes, right? JavaScript, most people don't realize, JavaScript doesn't have classes. It has objects, and it has inheritance. But it doesn't have classes in the sense of OOP, And for example, it doesn't make real sense to talk about things like Liskov substitutability in JavaScript. The variable scoping rules have changed. There are some new constructs. Transpilers are becoming more and more popular. So if you've heard of TypeScript, which is basically a language that has strong type checking but can be compiled down to JavaScript. JSX, which is the language that you write your React apps in, also compiles down to JavaScript. Babel is a project that will transpile ES version 6 to older ES versions. Even though ES version 6 was introduced in 2015, a lot of browsers out in the field still don't implement it. So if you're deploying production JavaScript code, you cannot generally assume that the users are all ES6 compatible at this point. But there are transpilers that will generate underlying JavaScript code, JavaScript classic, as I like to call it. And I think the result of all this is pretty soon people won't be writing JavaScript anymore. People will be writing in one of these other higher level languages, transpiling down to JavaScript. And the common denominator is all browsers do have JavaScript interpreters. So, and it's Turing complete, so you can implement any language on top of it. In fact, there's a list of which languages can be compiled to JavaScript. And it's basically every language you've ever heard of or would care about. So I think JavaScript is going to be a target language real soon. And I'm actually not sure what's the best way to cover it in this class. But I will give you at least enough to understand how JavaScript is used in the browser, what the limitations are when it's used in the browser, how the basic mechanisms of things like AJAX work. Because if you understand that, you can understand how to use any of the frameworks that are built on top of it. And we will mostly focus on the use cases that have to do with enhancing apps that are largely server-centric but have HTML user interfaces. We'll talk a little bit about single-page apps that are JavaScript-heavy but still rely on a server piece. We won't really talk about anything as complex as Google Docs, which is all JavaScript at this point, or fully server-side implementations of SaaS apps using things like Node or Express. OK, so usually we get to JavaScript a little earlier in the semester than this. Nonetheless, here we are. And we got a little bit of an intro to it at the end of last week just to sort of get some positioning about it. And once again, oh, there we go. Since we haven't had a computer history minute in a bit, I thought this might actually be an appropriate place for one, because as it turns out, the two languages that we've been using in this class actually have a lot of common ancestry. So the languages Smalltalk, Lisp, or Scheme if you prefer, which is sort of a Lisp dialect, and Self, which is a lot less well known, are intellectual ancestors of both Ruby and JavaScript in important ways. The pure object model that we saw in Ruby, where everything is an object and everything is done by sending messages to objects, that really comes directly from Smalltalk, which was a language that was developed in the early 1970s as a sort of experiment in pure object-orientedness. We've already seen that Ruby has some idioms that come from the functional languages world, like map and collection operations and things like that. As we're going to see, JavaScript actually has a lot of the same thing. And those are great ideas that come from Lisp. Lisp also was one of the first languages to really give us closures, which is the idea that a procedure can see all of the variables that are in scope at the moment the procedure is defined. And then if you call that procedure later, it has access to all those variables. We use that all over the place in Ruby, and even more so in JavaScript. JavaScript's first-class functions and closures come very much directly from Lisp. And finally, Self, which is a language that is less well known, but the inheritance model that classic JavaScript comes with, and the fact that that model is different from what we think of as traditional object-oriented classes, where you sort of stamp out instances of a class, but those instances really all are constrained to have the same behavior. JavaScript objects don't quite work that way, although people sort of try to shoehorn them into that mold. And the inheritance model they do work from, which is called prototype-based, actually comes from Self. And by way of trivia, Smalltalk is the language that was used to develop arguably the world's first graphical user interface. That's a screenshot from, a very bad screenshot, I'm afraid, from the Xerox Alto. Anybody know about what year the Xerox Alto did a demo where they showed windows that were draggable and a mouse and pop-up menus, basically everything you now think of as the basic elements of a graphical user interface? Anybody know roughly what year that was demonstrated, like on a real research prototype that you could actually use? Or want to guess? Shout out a guess. 75. Really close, 73. And the ideas had actually been demonstrated 5 years before that in a demo that I'll probably talk about sometime before the class is over, called the mother of all demos, that happened right here in San Francisco. And Self, like I said, not a language that has a lot of recognition, but it was the language that was the basis of a Newton script. I didn't bring it today, but a couple of days ago at the Computer History Museum, there was an event celebrating the somethingth anniversary of the Newton. The whole design team was there, and I got them all to sign my Newton. I was very excited. So I'll bring that in as a show and tell piece shortly. But you programmed it in this weird little language called Newton script that actually was heavily influenced by Self. So you know, most of the good ideas in languages are not really new. They're recycled, and they just sort of get remixed with good ideas being stolen from different languages every time a new generation of them comes out.
All right, so that's the second video. A big picture about JavaScript. If you don't really understand what he's talking about, it's totally fine. Basically, the professor talks about different characters of JavaScript. But unless you have already some experience with programming and with different type of programming languages, it will be difficult to understand. So I would say, like, if you feel like to revisit this video after you learn some different programming languages and use it at least in some projects, or after you take the compiler class, then you could revisit this video, and then you will probably be able to understand what he's talking about. Otherwise, it's totally fine. It just tells you in the big picture how JavaScript is different from other programming languages, its primary use case, and yeah, its features, where these features come from, and that actually comes from other programming languages that's invented earlier than JavaScript. Alright, let's get to the third video.
Let us try the 8-step plan for JavaScript. And probably at this point, y'all don't remember what the 8-step plan is. But back when we started looking at Ruby as a language, I said there's, as a seasoned software engineer, what you want to think about is not what language do you know, it's what is your game plan for picking up a new language. And I had proposed kind of this 8-step outline that you could use to approach a new language and sort of quickly get your brain into how to think in that language. So we're going to try that same template that I suggested for Ruby with JavaScript. By the way, everything that applies in terms of making your code beautiful and highly testable applies for JavaScript too. It's just in some cases a little bit harder to do. But all of the same guidelines and things that I've been hammering on in Ruby, functions should be short and have few arguments and do one thing and stick to one level of abstraction. That's fundamentally something that any good code should have. So keeping your JavaScript code separate from your markup, although depending on if you're using a client-side framework, that will go out the window. But for now, we're going to stick with that. I've been a stickler about trying to do test-driven, if not test-first development. And this idea of red-green refactor, where you actually try to write a test at the same time as you're writing the code, and then you're incrementally developing the code to make the test pass. We can do the same thing in JavaScript. And in fact, Jasmine, which is a JavaScript testing tool that we'll get an introduction to, was deliberately designed to look a whole lot like RSpec. So all of the same kinds of things that you can do, where you can set expectations, you can set up stunt doubles of objects, you can spy on method calls and return a canned value, all of those same facilities are available. They're just not quite as graceful to use. If you are going to spend a lot of time in JavaScript, you probably want to read Doug Crockford's book, JavaScript: The Good Parts, although some of what's in there is going to be, I think, obsoleted or rendered superfluous by ES6. And there's a whole bunch of different lint tools and sites and things like that that will help find common problems in your JavaScript. If you're already using CodeClimate, you're certainly using it for the project, but if you are doing JavaScript coding, I strongly suggest you continue to use it because they now have a pretty decent JavaScript linting engine too. So what is our 8-step plan? As a reminder, here's how the 8-step plan works. To approach a new language and start learning to think in it, we first ask, how does the language handle types and typing? Does it have strong typing like Java? Does it have dynamic or weak typing like Ruby? What are the primitives in the language? Are there primitive types of things? Are there primitive operations that are built in? How do you do bread and butter stuff like control flow, conditionals and loops? What are the basic types and things you can do on them, like strings? How do you talk about methods, or depending on which language, some languages prefer to call them functions. That's what JavaScript calls them, or procedures. So how do you define them, and how do they work? Abstraction and encapsulation. How do you hide data? Is it like an object-oriented language with classes, where the data inside of a class is more or less hidden to that class unless you make it public? Can you put groups of classes together? Can you sort of namespace things in a different way? So what are the mechanisms for doing that? Idioms. What are the things about writing code in that language that are going to look different from other languages that you may have used? And when we started Ruby, this was the one that I kind of referred to as, you can write Fortran in any language. If you try to carry your coding habits from one language to another, very often you'll find yourself writing code that is not idiomatic, that experienced programmers in that target language would find awkward or difficult to read. So for example, in Ruby, you very rarely see, let's say, an explicit for loop iterating over the elements of an array. Instead, the Ruby idiom is you use each, and you provide a block that specifies what to do, and you let the collection manage its own traversal. So that's an example of a Ruby idiom, and as we'll see, there's a couple of idiom patterns that are all over the place in JavaScript, and that it's kind of hard to write serious JavaScript code without running into them. In future lectures, we'll talk about libraries and dependency management. The answer for JavaScript is a little bit different, in part because in the scenarios that we're mostly looking at, that JavaScript code is being delivered down to the client. And there's, on the development side, you want to be able to have your code broken up across all different files and sort of structure it in a way that is easy to maintain. But on the client side, what you want is to deliver that code really fast and maybe compact, minified or uglified or obfuscated. So a lot of what we'll talk about with libraries and dependency management will figure in what's called the asset pipeline. How do you debug things? What does the IDE look like? If you go sort of beyond the JavaScript console window in the browser, what other tools are available for debugging, and how do you make use of them? And how do you write tests? And for that, like I said, we're going to introduce Jasmine, which is a lot like RSpec as a testing framework for JavaScript. So my hope is maybe we can get through like numbers 1 through 5 today, and we can start with 1 and 2, types and typing and primitives. So JavaScript basics on the 8-step plan. And if you haven't tried it already, you can open a JavaScript console window in most browsers, and you can sort of try stuff out live. So how does JavaScript deal with types? JavaScript is interpreted, starting from that. Yes, there are JIT compilers, but fundamentally it's an interpreted language the same as Ruby is. It is dynamically typed, so variables don't have types, just like in Ruby. The objects to which those variables refer may have types, but the variables themselves do not. So like Ruby and unlike Java, you don't declare the type of a variable and then allow it to only ever name things of that type. The basic type in JavaScript is basically a hash. And in JavaScript, it's actually just called an object. The keys in the hash, if you're talking to a JavaScripty person, they may call those keys slots or properties. Those are actually names that descend from self and from Smalltalk. So here's a simple example of an object. I've assigned the variable movie, and we'll talk about the var keyword in a moment, to an object that has 2 slots, a title slot and a release info slot. The title slot has a string value. The release info slot has a value that is another object. So objects can nest. Notice that in my nested object, I chose to leave out the quotes around the slot name or the property name. They are optional if the slot name would otherwise be a legal variable name. So rating would be a legal variable name, but you can give slots names that happen not to look like a variable name. If you've been playing around with APIs, even beyond our very basic initial API assignment, if you're looking at JSON objects, right, and now it's quite clear where it comes from, right? JavaScript object notation is really just a way of deserializing or serializing one of these JavaScript objects. In JSON, it is always required that the slot names have quotes around them. So depending on the code you're reading, right? If you're looking at an object that came from a JSON API, you'll probably see quotes around every slot name. If you're looking at JavaScript code that defines objects with a bunch of slots, you'll often see the quotes being left out. So it's either way. It's like the 2 different ways of doing symbols in Ruby. You just have to get used to it. JavaScript is single-threaded. This is a source of much confusion among people who are approaching the language. There is no concurrency abstraction at all in JavaScript. There are no locks, there are no semaphores, there are not multiple threads, there is no parallelism of any kind. There are libraries, things like web workers, that make it possible to run multiple separate JavaScript threads, but each interpreter basically is running in its own thread. And this is a decision that goes all the way back to the fundamental design of the language. And hopefully, as we talk about the differences between the JavaScript programming model and others, you'll understand why that design decision was made and how it's a great fit for certain types of programming problems and a sort of awkward and uncomfortable fit for others. So that's the basics of JavaScript types is basically that. There are a few primitive types, like a number is a type. There are strings, there are arrays, and the basic object is essentially a hash. Browsers and scope. The JavaScript runtime is expected to have access to one special object that's called the global object, which defines a handful of things about how JavaScript is connected to the environment in which it's running. So when JavaScript is running as part of a browser, the browser defines a global object, among which, for example, one of the properties of the browser's global object is a JavaScript object that refers to the current browser window. If JavaScript were running, let's say, as part of a desktop app, in other words, if it were running not in a browser environment, or maybe it's running as a server on something written using Node or Express, the global object would have some quite different stuff in it. And the idea of the global window, let's say, wouldn't exist, because those are entities that are defined by a global object that in some sense ties the JavaScript interpreter to a particular kind of environment. This is one of the standard keywords in JavaScript, kind of like self is in Ruby. So if you use this in global scope, it's whatever the global object is. So if you were one of the people who, when I asked how much JavaScript have you seen, if you've looked at sort of other people's JavaScript and you see things like this.document.window or this.window, that's what's going on there. In the context of a browser, this names the global object if it has no other qualifiers, and the browser defines a global object with slots like window and document to describe what the current window and document are. If you see this inside the scope of a function, then it refers to the object receiving the call, just the same way as self would in Ruby. Okay, so get used to seeing this. Each page in a browser gets its own global object. Again, another source of much confusion. So, and when I say a page, it's not just the window, right? If the window is now reloaded from the server as the result of a new HTTP request that brings in a new top-level HTML document, then a new copy of the global object is created for that. So every web page is really pretty much isolated from every other page because the global objects are not shared between them. There's effectively no way for those pages to use JavaScript to communicate with each other. Now, again, there are tricks you can do. You can have a page that creates a pop-up or a child window, creates another child window, and thereby has references to both of them, and you can pass information between them. So there are ways to get that done. But in terms of the fundamental programming model, every window has its own global object, and for all practical purposes is independent of every other window. One consequence of that is, from the point of view of your server-based application that is serving HTML pages, every single HTML page has to separately load whatever JavaScript your app relies on. Now, that's not really as bad as it sounds. First of all, browsers are pretty smart about caching. And if you load a JavaScript file and then a few seconds later you have another page loaded that asks for the same JavaScript file, as long as the browser can determine that the underlying file hasn't changed at the server, it'll just use the local copy. So it is not the case that every single JavaScript page request will actually cause a new load. And as we'll see, things like the asset pipeline will go further than that, and they'll actually take all of the JavaScript pages of your app, mash them into one big blob, do a bunch of interesting compression, and cause the one big blob to be sent down instead. And for the most part, you get to be oblivious to that. So in terms of implementation, it is not usually the case that you're going to do a lot of separate JavaScript page reloads. But in terms of the programming model, that's what's happening. Every single browser page that gets loaded has its own copy of the universe, and any JavaScript code in your app has to be explicitly loaded into that copy of the universe. And when we talk about the asset pipeline, we'll show that Rails and other frameworks often have a higher level way for you to say as part of your page, load JavaScript required here. so that in development mode, it'll actually load all your little tiny JavaScript files that you can be modifying as you're debugging. But in production mode, it will cause all those files to be grouped up into one big blob, and then the blob gets served. Maybe you even serve that blob from a content distribution network or something else. Okay, so we'll talk about that when we talk about the asset pipeline. That's why it is not a problem at all to divide your JavaScript code across separate files. Just like in Ruby, you would sort of put each class in its own file. In JavaScript, each collection of related methods on an object, or if you want to call them a class with ES6, can go in their own file. You organize them to make them easy to maintain. So you find things in places that are sensible, not having to worry about the fact of how they're going to actually be provided efficiently down to the browser in load time.
Alright, so that's some basic stuff for JavaScript. We'll move on to the next video.
So back to our 8-step plan. So we introduced types and typing and how they work. The primitive types and operations, control flow, you've seen, there's if-then, same as in any other language, nothing special there. But let's talk about functions and procedures, and let's talk about abstraction and encapsulation. And for a couple of reasons, with JavaScript, we sort of have to talk about them together. And then we'll move on to these other topics. OK, objects and prototypes. This is one of the things that's just different about JavaScript. JavaScript does have objects, and it does have inheritance. But at least up until ES6, which we're not covering today, it doesn't really have classes in the sense that a traditional object-oriented programming language like C++ or Java or even Ruby has classes. Instead, the object inheritance model is based on this alternate concept called a prototype. And the basic idea is that every object that is newly created has a prototype. If not otherwise stated, then its prototype is just the basic object, which is you can think of as an empty hash. And if you try to look up a slot or dereference a property of an object, and the object doesn't have it, then its prototype is consulted, and so on up the chain. So there are some ways in which this behaves similarly to inheritance and classes, and some ways in which it behaves quite differently. In particular, the reason it's called differential inheritance is that any object instance can modify any one of its slots, essentially overriding, right, like the behavior of its prototype. But whereas in traditional object-oriented programming, I could have a subclass that overrides a method of the superclass, but now every instance of the subclass has that overridden method. In JavaScript, every copy of the object can potentially have its own version of the behavior. So it doesn't have classes in the traditional sense. So let's look at a few lines of code and sort of see what this means. One kind of object in JavaScript is a function object. Basically, it's an object that is function valued. And here, I am defining an example of one. And I'll get back to why I've capitalized the name of the variable in this case. But it is a convention. OK? What I have done is I've created a function object that kind of behaves like a constructor, but not really. And if I call this function object down here, and I say new movie, and I pass the 3 arguments that it expects, what does this function actually do? Well, inside the function, this is referring to a new object that is being created. So I'm setting the properties on the new object to be the things that were passed in. I'm also defining 2 functions. So again, you can sort of think of these functions as instance methods, because once I've got a copy of an object that was based on this prototype, right, that just means that the pianist is an object that is built from this template. And it literally means that. It means that I took this entire template and I cloned it, but within the clone, I've changed the values of particular slots. The clone has its own copy of these functions, OK for kids and full title, but it can decide to overwrite them, right? So if in my specific object, I have overwritten the value of the OK for kids function slot to be some new trivial function. And that doesn't have any effect on any other copies of the object I've made. So if I had several more lines here where I have additional variables, and for each one I'm creating a new object copy, I can basically customize the behavior of every single one. That's the difference between prototypal inheritance and the kind that we see in traditional object-oriented languages. think of it as like once a copy of the object has been stamped out for you from the prototype, within that copy, you can modify its individual elements and not just its data valued elements, but its function valued elements. And every object can have sort of its own behavior. That's part of the heritage of self. A huge, 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 huge pitfall in JavaScript is this. Well, actually, there's two. Even though I've defined movie as a function, notice that I'm calling it with this keyword new in front of it. This is really important. So that's your cue if you haven't been paying attention to what's really important. I'm going to tell you a thing that's really important because this bites people in the butt all the time. It would be perfectly syntactically legal if I take out the word new from this example. This is a legal JavaScript expression because movie is a function. I have some arguments. I'm just calling the function with some arguments. However, you should probably not do that if the goal of this thing is to act as an object constructor. The tip-off of new is exactly the difference between just call the function versus use the function to create a new object of which this thing is the prototype. That second thing is almost always the one you mean. You almost never mean this. In particular, the return value of this is undefined, which is really counterintuitive. So even if this function had an explicit return value, which you can see it doesn't because it's going to construct the copy of an object, new means that's the object that I actually want returned here, right? Stamp out a copy for me of which this is a prototype. If I leave that out, then what I'll get back is an undefined value for the pianist. It will not be a copy of a new object. It'll be undefined, which is JavaScript's special value for a thing that has a name but has no definition. And that is almost never what you want, and it's tricky to debug. That is the reason that by convention, JavaScript programmers have adopted that you capitalize the name of one of these constructors if the way that it is supposed to be used is not as a regular old function, but as a constructor to make new objects with this kind of prototype. So if I had defined a lowercase movie, that would imply that that's just a plain old function. I'm going to call it, and it's going to return a value. If I'm defining capital movie, the implication is this is designed to function as a constructor. So if you ever see a call to capital movie without the word new, something is probably wrong. Okay? So by the way, many people consider this ambiguity to be the single worst syntactic design flaw in JavaScript. So you're fair warning. Another pitfall, the one highlighted in yellow down here, recall that in Ruby, a function call to a function that doesn't take any arguments, if you combine that with the fact that Ruby allows you to leave out the parentheses when it doesn't cause a parsing ambiguity, this may look like it's just a call to a function that you're not passing any arguments to, but it isn't. Actually, this expression refers to the function itself. So, and one of the idioms that we'll see in JavaScript quite a bit, actually, is that functions get passed around all the time. So, pitfall. In JavaScript, to call a function, you have to put the parentheses around it. Even if the function takes no arguments, OK, then you have some empty parentheses. But if the parentheses are not there, you're not actually calling the function. You're referring to the function itself. And in a couple of slides from now, we'll show some examples of the 1,000,001 places in JavaScript where that is exactly what you're supposed to do, is refer to the function itself. OK, so just to summarize, when you're calling something that is a constructor-like function to stamp out a new copy of an object having this as its prototype, make sure you use the word new, because otherwise you'll get an undefined return value, and it'll take you forever to debug, and then you'll hate yourself. Any questions about my little snippet of code on this slide? This is to start getting you accustomed to what the language looks like. Yeah?
Earlier you had called the movie up, or you made a JavaScript object notation for up, and it's just bar movie.
Let's find it.
It was 7 or 8 slides ago.
Yeah, I'll find it. It's here somewhere. There? That one?
Yeah.
OK.
So in this, if we were to just call movie, then that would spit out the JSON.
So in this case, in this expression, what is the final value of movie? It's just an object. It's not actually a function at all. Okay? So here, movie just refers to this hash. You can't call it because a hash isn't a thing that you can call. Whereas in the slide that we were just on, so in this slide, the value of movie is a function. right? So in this case, the value of movie is a thing that you can call. You can try to call anything, but if the thing you're trying to call isn't a callable thing, it's just an error. So the fundamental difference between the previous slide and this one is that here, I'm defining movie to be a function. That's what allows me to talk about calling it. Does that help at all?
Yes.
Yes with a but, or yes?
Yes. Basically, what confused me was that you're calling this var, or you're saying var movie, and then you have the JSON right there. But like, if you wanted to refer to something else as, say, another movie, The Pianist, then you would have to call that also The Pianist.
Right. So the way to think about it is movie is just a variable name. And unlike, so a thing that you cannot easily do in Ruby is you cannot assign a function valued object to a variable name. In JavaScript, you can. And that's the confusion. And this is why when most people who are coming into JavaScript from C or C++ or Java, none of which have first-class functions, right? A first-class function means a function has the same standing as an int or a string or an array. It is an object that can be passed around even if you never call it. For most people, JavaScript is the first language they work with where that's a thing. And it's a really important thing because that ability, that property is actually used all over the place. So in this example, I have created a variable whose value is a function. In the previous slide, I created a variable that happened to have the same name, but its value was just a plain old object, a hash. And hopefully there's a little more code coming up that I think will even make the distinction even more clear. So thank you for asking. Other questions on anything on the, any questions about my little code snippet here? Yeah.
Do you have to do var m equals new movie, or just do var m equals one?
If you mean like what happens if you leave out new?
Yeah, when you're trying to refer to the function itself.
Oh, yeah, if you're trying to, yeah, the example's a little contrived because you wouldn't really want to refer to this function, but yes, if you left out new, yes, you're right. In fact, actually, I'm not even sure that new is legal in this context. But yes, this assigns m to the actual function object. It doesn't call the function. It just makes m point to the same thing, which happens to be a function-valued object, right? Functions are fun. We're going to learn to love them in just a moment. OK, so other questions on the code? If you get this concept about function-valued objects, you're halfway through today's lecture in terms of the important concepts. So summarizing JavaScript's single worst syntactic design flaw. If you call a function using new, then what you're going to get back is a new object whose prototype is the thing that you called using new. So think of it like initialize in Ruby. It's basically stamping out a new instance of something. The instance is a copy of the prototype, but once you've got that copy, you can modify its individual properties without affecting the prototype and without affecting any other instances that were similarly created. If you now take that thing that you got back and you call a function on it, then within the body of the function, this is bound to whatever the object is, just like self in Ruby. So once you've created an instance of a class and you call a method that is an instance method of that class, within the instance method, self means the copy of the object that received the call. Same thing in JavaScript. This refers to the specific JavaScript object that received the call. If you call a function without a receiver, so if you see a function call that doesn't have an explicit receiver on it, in other words, just like in Ruby, if there's no receiver, the receiver is assumed to be self, and then you have to figure out, OK, well, what is self bound to in that context? Same thing in JavaScript. If you call a function and there's no obvious context in which it's called, this is assumed to be prepended to the front of it. And if there's, by default, this is the global object, which is almost never the thing you want. In the case of a browser, the global object happens to be a thing called window, which has a bunch of properties about the window being displayed. In a non-browser context, the global object will be something totally different. But be very careful if you're calling a function without an explicit receiver. And finally, if you have a constructor-like function, but you forget to put in the word new, unfortunately, it is not an error to do that. It is legal, but it does a thing that you probably didn't intend, which is that you do not get a brand new object. Instead, you get undefined. And then good luck debugging that, because that's the equivalent of trying to, getting an error message that you're trying to call some method on nil, and it's not defined. OK.
OK, quick pause here. Just a quick comment. I personally don't really think that's the single worst design flaw in JavaScript. of course, if you're writing a project in vanilla JavaScript or the classic JavaScript, you may run into these issues. But honestly, these days, you don't really need to use vanilla JavaScript. There's a few things that has been mentioned, Babel, TypeScript, what's the other, JSX, and spiders or the higher level languages, they all implement OOP or classes. So you don't necessarily need to deal with this prototype-based inheritance. So the main difference, like comparing JavaScript or classic JavaScript and other OOP languages like Java, Ruby, or even ES6, is basically JavaScript is when we talk about inheritance, it's prototype based rather than OOP or based on classes and all that. So yes, if you're not comfortable with that, and if you're not familiar with that, this idea of prototype-based inheritance is going to be difficult, and it will cause bugs here and there. But honestly, in most, at least according to my experience, in most of the web applications, front-end JavaScript are typically simple enough that don't really need to use inheritance to dry out code. Or if a project is complicated enough, then most likely you will be using a transpiler or a higher level languages like TypeScript, like Babel, like JSX, to deal with inheritance in a more familiar way, that is using class. And then also if you're using frameworks such as React, Vue, Angular, they all already have those stuff built in. So most likely you're not dealing with classic JavaScript or vanilla JavaScript. So even though it still supports prototype-based inheritance, most likely you won't actually need to use it. Of course, if you are joining some existing project, you never know what to expect. But otherwise, honestly these days I really don't see many projects that necessarily need to use prototypes. And then I have an opinion on what's indeed the single worst thing in JavaScript, but we will talk about that later. Okay, we will continue with this video.
Continuing on the 8-step plan, that was step 3 where we were talking about functions, and I said that together with that we were going to talk about abstraction and encapsulation. They sort of go together. So I think one of the things that last example drove home is a function is a first-class object. You can pass a function around, which is different from calling it. And that's extremely common in JavaScript, is passing functions around for reasons we'll see in a moment. Functions are also frequently property values. So even in that clicker question that we just did, the object that we were defining, that square constructor, it has a property that is the length of the side of a square. That's just a plain number. But it also had a property that is function valued, which is a function that computes the area based on the side. So they feel like instance methods, although we don't really have classes, so they aren't really instance methods. We'll talk about ES6 separately, but what you saw was an example of prototype inheritance, where you stamp out a copy that has the same slots, and it can just look up the slots in its ancestor. We've seen the var keyword a number of times here. Basically, it restricts the scope of a variable to the function within which it occurs. It is almost never the right thing to leave out the word var, because if you leave it out, it's implying that your variable is being declared globally, and you almost never want to declare variables in global scope. The one exception is, well, then how do you sort of keep track of all the stuff that is associated with your app? it's considered a best practice to create a single object and give it a name that's in the global scope. And then inside that object are the properties that store all of the functions and all of the data that your app cares about. So for example, I might have some JavaScript code associated with my Rotten Potatoes app that looks like this. The first thing it does is it defines a single top-level variable. So because it doesn't have var in front of it, this is going to be defined in the global scope. The initial value of RP is an object that has no properties, so think of it as an empty hash. But I'm immediately going to start creating new properties in that hash. I'm going to have a setup property, and that's going to be a function that maybe does some setup things when the page is first loaded. I'm going to have another property called getMovieInfo, which is another function that maybe makes an AJAX call to the server, about which more on Thursday. Another way to write this would have been something like this. In one fell swoop, I can create a single object and say, here's my opening brace of the object, and here are the slots. Same thing. One reason that I will often use the top form is because as long as I know that some JavaScript file has been loaded early on that creates a definition for this object, then in my other files I can add other properties to it and not worry about polluting the global namespace. Okay, so multiple ways to sort of
another quick pause here. Let me bring up my window. Wait a second. Okay, so what we typically see instead of blah blah blah. So what we typically see, instead of doing this, you will see people do that. And then sometimes you can just ignore window. Basically, what we're trying to do here was that bar is basically saying if RP is already defined, use RP already. So we are assigning RP to RP. So we're basically doing nothing. Otherwise, if it's not defined yet, then assigning an empty object to RP. So that's actually more common rather than the one you see in the slides of the original video. Because imagine if that code somewhere else in the application, write that code again, then it basically wipes out everything that's already defined for the RP global object. So just one correction I would say. Try not to do that in the way that's in the video, but do this. Okay. Remove that. Right. We'll move on.
keep track of what all is in your app. But this is a recommended thing is your app is going to add at most one thing to the global namespace. And because that thing can include arbitrary nesting, all of the stuff related to your app-specific JavaScript functionality is in there. Any JavaScript functions that you write are just function-valued properties. Any data associated with your app are JavaScript slots. Of course, keeping in mind that as soon as another page is loaded, that all gets blown away and reinitialized, because every page is a brand new, fresh copy of the interpreter. OK? 8-step plan, moving on. So we've talked about types, typing, methods, abstraction, encapsulation. Let's talk about JavaScript idioms. And again, this is where there are things that are very common in JavaScript that most people have not experienced coming from other languages, unless they've done like Python or Scheme. So if your 61A chops are still good, This will be easier. Okay, passing functions around. One of the most common JavaScript idioms, in fact, it's almost impossible to get any serious work done in JavaScript in the browser without using this idiom, is the idiom of passing a function to something, usually because that function is going to be called at some later point in time for some reason. For example, in the early days, before there were JavaScript frameworks like jQuery or anything like that, one of the standard calls that was provided by the browser's JavaScript API, and remember that document is a thing, if there's no qualifier in front of a name, it's assumed to be this, and in the global scope, this is the global object. So this, I could have also written the first line, this.document.ready or window.document.ready, because for a browser, the global object is a thing representing the browser window. So in this first line, one of the standard calls that a browser would provide was called the ready function. And what you pass to the ready function is a function. And the browser promises that once the page has been completely loaded from the server, it will call any of the functions that are in the ready list. You can actually have multiple ready functions. Why do you need this? Because, for example, you might have JavaScript code that expects the page to have been loaded, expects some element to be somewhere so that it can animate it or highlight it or whatever. But in fact, the order in which the browser loads chunks of the page and chunks of JavaScript is not necessarily predictable. So the ready function provided by the browser gives you a hook that says, when you, the browser, can guarantee that everything is like ready to go and fully loaded, then call my setup function, and my function knows that it's going to find everything organized in the right place. But here's a valuable example of where you're not calling the setup function at this point. You are passing the function itself because the expectation is someone else is going to call that function later. When frameworks like jQuery started to pop up, they actually replicated that same idea. They have a notion of a ready function, but jQuery does a bunch of other stuff for you and then calls all of your ready functions because it will arrange to pass them down to the browser. So in both of these cases, the key idiom is you're passing a function because someone is going to call that function later under some well-defined set of circumstances. Another idiom that if you're reading complex JavaScript code can look a little bit disorienting is what's called immediate application or calling a closure. So suppose you see something like this. Function, a bunch of stuff in a function. Maybe the function has some side effects. And then this is what I call like the jungle of JavaScript parentheses. You're going to lose many valuable hours of your life counting and matching up braces and like curly braces and parentheses in JavaScript. So use an editor that understands JavaScript. But what's going on here? First, we're defining a function, and we're not assigning it to a variable or anything, right? We're just saying, here's a function that does some stuff, doesn't take any arguments. Here's the end of the function. So the value of everything from this open to this closed paren is a function object. Then we put empty parens around the function object, so that causes the function to be called, right? So we created a function. We didn't assign it to anyone. It has no name. We can never reference it again. And then we immediately called it. The reason to do this is because if this function has side effects, it creates new variable names, none of that stuff will escape the application. It won't escape the closure of the function. So anything that happens in here, in some sense, is saying, here's an environment. Remember environments from Python, environment diagrams? Everything in here is an environment. And the function is now going to be applied. We're going to call the function. Once that's done, that environment is blown away. It evaporates. So anything that we defined in here, any side effects that we had, whatever, the side effects will still happen, but we're not going to pollute the global namespace. It's a way of containing the pollution of variable names and things like that. And this is an extremely common idiom. A function is defined in place, immediately called, and then never spoken of again, because we didn't assign a variable name to it, so we can't like refer to that function anymore in the future. Another JavaScript idiom that involves passing functions around, iterators. Very much like Ruby. In fact, each is a method that is defined, well, it's defined basically in JavaScript, but jQuery defines its own method. In jQuery, you can say something like, find all of the HTML elements that have the CSS class called SomeClass. And then on each of those elements, here's a function saying what to do to it. Actually, this is a typo because there should be an argument here, which is the thing that matches each element. Let me fix that in real time. There. OK. Wait, I screwed up the formatting somehow. There. Okay, fixed in real time. So, which is, by the way, which is a way of saying, this is just like in Ruby, right? When I call jQuery with some selector that is going to potentially match a bunch of elements, what is the type of the return value of that? Because it's not really an array, it is an enumerable collection. So just like in Ruby, the abstraction of saying, I have an enumerable collection, and I'm going to call each on the collection, and I'm just going to provide a function saying what to do with each element, but the implementation of how the elements are traversed is not up to me. Right, so it's very much the same as the Ruby idiom, although here we're explicitly passing a function, and each time through, a single matching element is going to be passed to the function, and you can do whatever you want in there. Another way to express the same behavior is in my single top-level global object, maybe I've already defined a function that, given an element, does something interesting to it. And now I can say, for every element that matches this CSS query, I'm just going to pass my function into each. Exact same thing. The only difference is that here, I have the function explicitly spelled out. Sometimes it's called a function literal, because I actually have the function spelled out in line. Whereas here, the function has already been assigned to a variable, a function-valued variable, and I'm just passing that instead of defining the function name. Okay, but what the overarching idiom in all of these cases is, here's a function, and you're going to call it in some specific context. It could be that you're going to call it when the page is ready. It could be that I'm going to ask you to find elements matching some criterion, and then you're going to call the function and pass it each element in turn. But passing functions around is one of the big abstractions that is used everywhere. And by the way, when we start talking about AJAX, it'll become clear why this is an important abstraction. Because if you make an HTTP request to the server as part of an AJAX call, that request could take quite a long time to come back. And I said earlier that JavaScript has no concurrency. It's a single-threaded language. So if JavaScript were to just sit there and wait for the server to reply, then in that intervening time, the user interface would basically be frozen, right? JavaScript would be unable to respond to actions happening in the UI because it's sitting there waiting for the answer to come back. So in fact, the way that those calls are always made, and this is the subject of the next slide, is make the call to the server, and here is a function. When the server returns an answer, pass the answer to that function, and that function will do whatever. And it's up to the browser and the runtime system to figure out when to schedule that as part of the single thread that's in the interpreter. So here's what that looks like, because this is the other very common pattern that is used to handle basically any kinds of UI events. So suppose that, again, following my good habit of only defining my own functions in the namespace of my global object, I've defined a function that takes some data and it does something if there was a successful call. So let's say I'm making a call to a remote API, and hopefully what I'll get back is data. That would be success. Or I might get back an error message. And I've defined two different functions. One of them is the thing to do with success. The other is the thing to do with failure. And maybe what I do is now I'm going to make an expensive API call. I have some way of arranging to make the call so that when the call eventually completes and the underlying runtime system notifies the JavaScript interpreter, hey, this call has a response, then depending on whether the response was a success or a failure, I've passed both functions and say, here, call the appropriate one of these. In ES6, there is a generalization of this, and it's actually also defined in Node.js called a promise. And a promise is basically an encapsulation of the state of a long-running operation whose result won't be known for a while. So here's another formulation of the same thing. Under the promise syntax, basically anytime I create a promise, I have to pass it a function that has two arguments, a thing to do if the long-running operation succeeds, and a different thing to do if it fails. They're usually called resolve and reject, although they don't necessarily have to be. So in my make expensive call function, what I'm going to do is I'm going to do whatever the long-running thing is, and if the long-running thing works out, I will call the resolve function. If the long-running thing does not work out, I'll call the reject function. And then in my code, and if you've read code that is designed to run in something like Node, you've probably seen this, right? Whoops, hold on. Yeah, so make expensive call, then something, then something. This is basically a way of saying, if this were a blocking language, I would just do these things one at a time and wait at each step. But this isn't a blocking language, and each one of these things has to be handled by kicking off the expensive operation and relying on a callback to be called at the right time when the response returns. Because that sort of code is difficult to read, then promises and this syntax for then were essentially invented as a way to make it, read the same as if you were doing a strictly linear blocking implementation. And to me, this captures why JavaScript makes, to me anyway, a lot more sense to use for the user-facing part of an application than to use for the server-side part of an application. Now, this is a matter of opinion, but let me explain where my judgment's coming from. If what you're doing is enriching the user experience of a UI like the browser, you don't know when the user is going to do an action and what action they're going to do. So basically, your life is spent waiting for the user to do something interesting and then reacting to whatever the user did. Or if what the user does causes a request to go to the server, now you're going to have to wait for the response from the server and do something to react to whatever happened there. So in the client, you're living in a world where you're not sure what's happening next, and that's fundamentally called an event loop. You are sitting waiting for an event to happen. You don't know which event is coming next, but you have a way to deal with it when it occurs. And you can attach event handlers to different things on the page. So if the user clicks this button, here's what you do. If the user drags this thing from here to there, here's what you do. And as you can imagine, every one of those is expressed by passing a function to something saying, here's what you do function. On the server, life is very different because from the point of view of the server code, every server request looks the same. You wait for a request to arrive, and you know it's an HTTP request. You parse it and figure out which function to call. You call that function. Maybe it talks to the database or does some computation. And eventually, it returns something back to the client, a JSON object or an HTML view or whatever. Every single server request follows the exact same sequence of steps in the same order all the time. Now, does that mean that those server requests don't sometimes block? Sure, going to the database could be expensive, but most modern operating systems have a way to handle that by either having multiple threads on the server or multiple copies of the server process. So you still have the issue that when the server is hung up doing something, other requests get to run. It's just that unlike this scenario, you don't have to manage it yourself. So my point of view happens to be that if the programming model you're dealing with is fundamentally task parallel, which means every task has basically the same structure, basically the same set of steps, but you need to have multiple of them in flight at the same time in case one of them gets hung up. Blocking imperative languages are a great fit for that because the underlying thread system does the work for you of deciding when it can schedule a thread that's runnable because another one's blocked. But if you're in a world where you don't know what's going to happen next and you're sitting there waiting for the user to do something, then in a world like that, event-based programming makes a lot of sense. You have an event loop that waits for the next thing to happen and you react to that thing. And because there's no concurrency in JavaScript, you have to react to the thing by never blocking. Anything you're going to do has to return immediately. So you can kick off a request to the server, but you can't wait for the answer. You have to provide a function saying, when and if the answer eventually comes, call this function. Or if the answer comes back and it's an error, instead call this other function. Or if it times out, you've waited a certain number of milliseconds and nothing has come back, then call this function. And you end up having to manage it all yourself. So that's my 2 cents on models of programming and why I think JavaScript is potentially a better event-based fit for user-facing stuff than for server-side stuff. And I think the server-side frameworks have made a lot of progress in making it possible to write code that essentially looks sequential. The only improvement over that I can think of is to write code that actually is sequential and have the operating system do that management for you. It's probably true that if you get very good at this style of programming on the server side, you can do more things in less memory by doing this sort of event loop style programming compared to the amount of memory it would take to have n copies of a task and have the OS manage it for you. So there's sort of a standard argument that if you can get this kind of programming right, which is difficult because debugging asynchronous code is inherently tricky, right? You do something and then sometime later in a disconnected place you deal with the response. But you get more bang for the buck out of your servers if you can do this. I would rather pay for more servers and spend less programmer time if it simplifies the programming model, because the number one thing that I have to worry about is things don't work correctly, right? Performance is great to optimize after you've gotten things to work correctly, and I just think picking the right tool for the job is a way to maximize getting things to work right in less time. So that's my view.
Alright, there's something more about JavaScript. Some more comments here. And then, in my opinion, of course, you can have your own judgment. The single worst thing in JavaScript is that it's non-blocking, or it's event-based. But in some perspective, it's not technically a flaw, because JavaScript, the use case of JavaScript, is designed that way because it has to interact with user input. So it has to be kind of event-driven, non-blocking, otherwise the UI will hang. But still, it's kind of the single worst thing, because it's designed based on that. Of course, there's no way actually to avoid that. It's very easy to see very many ugly code out there with programmers don't even understand like what's going on with the event-based programming. And because everything, the codes are executed out of the normal flow, it's not like from line 1, 2, 3, 4. It has fallbacks, and then it always jumps here there. Like in old school programming languages like C, Fortran, there's usually a way for you to have like go-to statement where the code runs to here, then suddenly jump to someone else. And for a program that uses go-to, it's usually difficult to understand and debug. Same idea here, like for event-based, because the sequence of execution is jumping around here and there. It's typically difficult to understand what's going on with the code and what happens when. And also when you debug, and for example looking at the stack trace, most of the time it's out of context, because part of code was executed by triggering some events, but sometimes the context of that code is not simply just because of that event. There is something prior to that event, that set up the context, that set up some variables, but because it's stripped out of the context, then when you look at the trace, it's difficult to understand when and what actually triggers that function call or something like that. And there's another thing called callback hell. Basically, when callbacks gets nested more than certain levels, then the code becomes difficult to understand and read. And then I've read many code that has that bad smell. Of course, there's ways to counter that. One thing is the promise, and this promise that's mentioned, and it was actually introduced pretty recently, and it really helps to convert non-blocking code into sequential code. And then the other smelly thing I typically see from people who don't really understand JavaScript or write JavaScript is that because they don't understand, it's event-based, and it's non-blocking, so the code are actually executed out of order. So the way some programmer would walk around that is wrap certain part of code with set timeout, basically kind of delay the execution of certain part of the code. So for example, if I have code, the first part of code is sequential, and then there's one line that triggers an event, and then it becomes non-blocking, and then it will return and then call another callback, and then I actually want the second part of code to wait until that callback is done. So the ideal way, or the good way to do it, is to just kind of implement another callback that waits for the first callback to finish. Or with like with promise, you could do it like then with then statements, or with async or wait, that kind of feature. You could do await, something like that. But then with new JavaScript programmers, typically we'll see is that for the second part, instead of waiting for the first callback to finish, they just wrap it with set timeout, like wait 1 second, set timeout 1 second, then run this code. Of course, in most of the case, it can work around the issue, hoping that the first callback will return in 1 second. Then it kind of can execute in the expected order. But let's say something went wrong, like the network is super slow or the computer is super slow, so it cannot finish the first callback in 1 second. Then stuff goes in the wrong order, and then because the code is not designed to handle that, then it crashes or run into bugs, errors, and all sorts of issue would happen. And I imagine that kind of thing happen a few times, where the first part waits like 100 milliseconds, the second part with another 100 milliseconds, then things can go really out of order and get messed up. So that's my opinion. And of course, a seasoned JavaScript programmer should be able to avoid this kind of pitfall. And then more on the event-based model. So because JavaScript is event-based, so there's certainly things that is really good at. And then recently I've actually run into a project that really needs the event-based model or event-based programming model. Basically, in that project, the application need to fetch data from like 20, 30 different APIs or RESTful APIs, and then using that data to render a page. So now imagine if I do it in a sequential way, then the program need to call the first API, wait for it, and then do the second API call and wait for it and do the third API call. And then now imagine if each API on average takes 100 milliseconds, and then by calling 20 or 30 API calls, it will take at least like 2 or 3 seconds before the web page can respond. Then in this rare case, sequential model doesn't really work. So one alternative is to use multi-threading, so that each API call can have its own thread, and then once all the threads complete, then merge the results. So that's one option. But typically in a language, in a sequential language like Python, Ruby, Java, it will take time, take some code to handle this multi-threading logic. Whereas in JavaScript, because it's already native to event-based, so I could actually just fire all these 20, 30 API requests in concurrent with concurrency. Although the professor said it's not concurrent, yes, it's in a sense not concurrent, because still making the request, sending out the request is sequential. It's not sending out all 20, 30 requests at the same time, but because sending out the request only takes, let's say, 10 milliseconds, so most of the time for API call is waiting for the request to get the response. So now it actually makes sense to go with event-based programming model, because I just fire all these requests really quick and then just wait. And then the slowest one returns, then I can merge the result and then start to render the page. And then it can speed up the whole process a lot more compared to the sequential model. So there are so many use cases for event-based programming, even in server side or backend. So yeah, that's something I want all of you to be aware of. Oh, and then the other thing I do want to mention is so JavaScript in general in complex projects, it's a bit difficult to manage its complexity, and then debugging, all that kind of thing compared to other programming languages. One of the reasons is it's event-based, and there are a couple of other reasons due to its design. But on the other side, like we mentioned a few weeks back, we've talked about SOA, or architecture or design, or server-oriented architecture. And then one of that these days are very popular is microservices. So basically the code base is broken down into small pieces. And then because everything is in small pieces, so if we look at every single individual service, the code base won't get too complicated. So in that sense, it can still be manageable to use JavaScript to implement pretty complex applications, given that you go with microservices architecture or design pattern. Basically by breaking stuff down into small pieces, even though JavaScript is in general more difficult to manage in complex projects, but with microservices we can kind of still make it manageable. Alright, let's get to the next video.
Today, when I talked about JavaScript briefly last week, one of the things I mentioned is the transition to version 6, ES6 for ECMAScript, is largely complete. We haven't really updated the course materials to reflect that, and there's a lot of changes in ES6. That being said, though, a lot of things about the fundamental way you think of the programming model associated with JavaScript hasn't really changed. So, and the way that JavaScript interacts with the browser in particular, if you're doing browser-based apps, has not really changed. So a lot of the basic stuff we're going to talk about, even if you find yourself using JavaScript frameworks, which we're not going to have too much time to talk about, the underlying concepts are going to be really important. So we're going to talk about basically what are the moving parts that are involved, whether you're doing a standalone mobile app using something like React Native, or whether you're doing a web-based app with or without a framework. What's the sort of programming model that allows these rich experiences to work and to be coded in JavaScript? What are the minimal set of concepts that explain how this works? So what are the what's the basic machinery in JavaScript that lets this happen? And how is that maybe different from other languages you may be familiar with if you haven't done a lot of JavaScript programming? And Thursday or possibly Tuesday, I will try to talk a little bit about a few of the menagerie of JavaScript frameworks out there and give some guidance about what makes each one different and when you might think of using one over another and stuff like that. But let me, just as a random poll, I'm interested in having a sense of like how much JavaScript programming people have already done. So I don't have like a prepared multiple choice question on it. But if you could use your clicker, and we're going to use the following scale. A means you've basically never written any JavaScript. Like maybe you've seen some, but you would not. Column folks, when the time comes, we'll help out your column A and column B peers who are needing some help with this, maybe on their project. So, bonus points if you have, if there's teams that are struggling with JavaScript-related things in their project, and you answer their questions on Piazza, and it's helpful. Philanthropy points are always good. So, okay, well, thank you for letting me conduct that little poll. It gives me a sense of everybody's expertise level. So, with that in mind. And I don't know why this thing kind of sometimes works and sometimes doesn't. But JavaScript has a sort of privileged position because it's in the browser. And by the way, trivia fact, the language that was supposed to be in the browser originally was supposed to be Scheme. It wasn't supposed to be JavaScript at all. And the thought was, well, scheme is like, people in the real world, normal programmers don't use Lisp. They don't understand it. It looks weird. Can we have something whose syntax kind of looks more like an imperative language, like C or even Java? And the syntax does look like that, but it's misleading because actually, as we'll see, the fundamental abstractions and the mechanisms, the way you think about JavaScript programming really comes much more from those other three languages, from Smalltalk, from Self, and from Lisp, none of which are traditional object-oriented imperative languages. So the syntax superficially looks that way, but don't let that fool you, because that's not how you think about the problem, how about the programming in JavaScript. But for better or worse, it is the language in the browser. So that means that unlike any other language, it can be triggered by user-initiated events that happen in the browser. So the user clicks on stuff. It can also cause such actions to be triggered. So just as it can be triggered if the user clicks on a button, it can also essentially cause the button to be clicked even without the user having done it, right? So it goes both ways. As we mentioned, after the addition of XML HTTP request, JavaScript acquired the ability via the browser to make a request to the server without automatically causing the content that's returned to make the page be redrawn. So it could make a request to the server, it could just get whatever kind of data back, and it could do anything it wants with that data. In fact, when the data comes back, JavaScript will wake up and be told, here's the response to the request that you asked for. And among other things, it can use that data to make changes to the current document, which could cause a change in the way the document is displayed. It could examine what the content of the document is. So this is kind of the privileged position it's in. It's the only language that gives us the ability to do this stuff. And today we're going to finish. If I could talk about JavaScript for like 3 weeks, but since we haven't had that much time, and this course keeps assuming more and more material until it bursts at the seams, as usual, what I'm going to try to do is give you an overview of what the world of jQuery and Ajax is like. How do you think about testing in that world? We're not really going to have time to do detailed examples, although I will say that there are detailed examples in the book with GitHub code, GitHub gist containing the code, and all the usual stuff. So when we last left off talking about JavaScript, I had made reference to this idea of the document object model, or DOM, which is basically a large data structure in memory in the browser that is the representation of the thing being displayed, the entire page. So the DOM itself is just a data structure. You have to think of it in an abstract sense. It is not a JavaScript thing, but via the JavaScript API, most browsers provide, well, all browsers now provide access to the DOM data. So we say that it has JavaScript bindings, right? But in no sense is the DOM actually a JavaScript entity. We mentioned that JavaScript can, by using that API, inspect the values of elements, including user-entered values. So it can ask things like whether a checkbox is checked or not, what the actual content of a text field is if the user has typed something into it. You can also make changes to the DOM, which have the side effect of causing what is displayed to change. You can remove elements from the DOM. You can temporarily hide them. You can change their appearance in various ways. You can disable them so that some controls no longer respond to user inputs. There are a number of issues historically where the DOM has not been implemented the exact same way across all browsers. So it used to be a much bigger headache than it is now, because you'd have to sort of test your JavaScript code independently on many different browsers to make sure you hadn't broken anything. These days, frameworks including jQuery take care of 99% of that for you. So basically, if you're writing simple JavaScript, there's sort of no good reason not to use jQuery. On Tuesday, I'll talk a little bit more about heavier weight frameworks. If you're thinking of learning Angular or Backbone or React, those go quite a bit beyond what jQuery does. So from this point of view, JavaScript is just another language. There's no reason you couldn't have bindings to the DOM from something else, but JavaScript is what was chosen for the browser. So the JS API, generally speaking, is the name given to the way that the browser makes various things available to you via JavaScript. And remember that JavaScript is single-threaded, so anything we do in the browser, any JavaScript that runs in the context of browser pages, has to not block for extended periods of time, because that is the only thing that is serving the UI thread. The user will perceive the browser page's UI to have frozen if the JavaScript blocks. So what does the low-level JavaScript API look like? All browsers have a very basic level of a handful of methods built in that are sort of your way to reach into the document object model. And probably the best known is getElementById. You probably may remember from Tuesday that when there's no qualifier in front of a variable name, it is assumed to be a property of this, and that in global scope, this is a JavaScript object representing the current window. So basically, we're saying in the current window, whatever the document is, the document has a function valued property that, given a string, it will return the JavaScript representation of the DOM element ID that, or the DOM whose element has that ID if one exists. And again, when I say the JavaScript representation, remember the DOM itself is abstract, right? So you're being handed a JavaScript object whose properties, whose slots, correspond to, for example, properties like what attributes does this element have? If it's something like a text field, does it have a value? Like, does it have text that was typed into it? And the browser arranges that if you make modifications to those JavaScript objects, they get reflected into the DOM. But the thing you have is not the DOM. It's just a representation of it. So you can also ask, given an element, tell me all of its child nodes. Because the entire HTML page is actually a single top-level element called HTML, you can, in theory, by being given just document, you can traverse all the way down, right? But you almost never do that. You usually use calls like getElementById if you know what you're looking for. Most people no longer use, or I don't see any good reason to use, just the low-level JS API and these calls. Instead, most people use a framework. For a while, Prototype and jQuery were sort of fighting it out. jQuery pretty much has won that battle. So jQuery is a framework itself written in JavaScript that essentially acts as an intermediate layer. And besides the fact that it fixes a lot of the incompatibilities across browsers, so the same jQuery code will behave pretty much the same way on all browsers that support it, it also adds a lot of useful higher-level behaviors on top of the very basic low-level JS API that I just showed an example of. And the basic idea of jQuery is that if you have a handle to a browser-native DOM element, like the kind of thing that getElementById might return, you can wrap that in a way that sort of gives it jQuery superpowers. It gives the element a whole bunch of new behaviors and the ability to do other stuff to it that if you were doing in the low-level API, you'd have to sort of manually write a lot of that code. So I'm going to give an overview of the way, sort of the most common things that people tend to do with jQuery and how they do them. The most important single function is a top-level function. So when you have your jQuery JavaScript tag, it adds a single thing to the global namespace. Remember, this is a JavaScript best practice, right? Add one object to the global namespace, and the properties or method calls associated with that object encapsulate all of the data and functions of the app. So in this case, the top-level name that jQuery defines is jQuery. And because $, is actually a legal JavaScript variable name, jQuery alias itself as $, which used to be a big mess because Prototype also used to alias itself as $. And if you inadvertently loaded both, badness would happen. But when you see $paren all over the place, that's what it is. $, is just an alias for this, which has various ways that you can call it. It's a function, and it's polymorphic, meaning that the way you specify the arguments determines what it does. So let us look at a couple of the behaviors that it has. The most common behavior you see is you use it to select elements. So if I have an expression like this, which again is just a shorthand for jQuery and calling the jQuery function with the string, this will return 0 or more elements in an enumerable collection form that match whatever this CSS specification is. So anything that is legal CSS can go here, and you can have arbitrarily complicated expressions. What can you do with the return value of that? Well, one thing you can do is you can call each. And just like in Ruby, when you call each, you're just providing a function saying, here's what to do on each of them. Anytime you have a method or function that returns a DOM element, if you just wrap it by calling $sign on it or calling jQuery on it, it becomes the sort of jQuery superpower-enabled version of that element. So it's a button on a form. It is a particular paragraph of text. The thing the browser gives you back is a low-level representation of the element. If you just call $, on that thing, you have sort of endowed it with the secret jQuery powers. And I'll show you on the next slide what a few of those powers are. The second thing you can do with the $, call is you can create elements. So here, the return value of it, what I'm doing is passing some raw HTML. And that HTML is going to be used to create this element. At that point, I can decide where to insert the element in the DOM tree, right? So now think of it as I'm holding a tree node. That's what else is going to turn out to be. And I'll show you some calls on the next slide where you can say, insert this node as a child of this other node in the DOM tree, for example. Almost all jQuery calls also return the element that they operate on. So for example, if I have asked jQuery to return to me the element or elements whose ID matches movies, and of course, if it's a well-formed page, there should be at most one such element. And then I say, for all of the elements that match this, add the CSS class main, and this call essentially returns the same thing that it was called on, if that makes sense. So basically, I can now continue to call additional functions, and every one of them is going to operate on that same return value. So a very common idiom in jQuery is you grab an element, or maybe you create an element, and then you do a whole bunch of things to it just by chaining the calls together. And then the third thing you can do, or a third thing you can do, is if you remember Tuesday, we talked about this idea of passing a function to be called when the browser decides the page has finished loading. The browser has a native hook for doing that, which is the onReady hook. But if you use jQuery's onReady hook, jQuery also has its own functions that it runs when the page is loaded. And this will allow your function to sort of get in the queue and be a first-class citizen along with them. So remember that this dollar function is polymorphic because the way you call it, the kind of thing you pass as an argument, determines what its behavior is. If what you pass looks like a CSS selector, then its behavior is to return all matching elements. If what you pass looks like raw HTML, then the behavior is create a DOM node containing that HTML and return the jQuery representation of the node. And if the argument that you pass looks like a function object, it means add that function to the list of things to run when ready. What can you do with jQuery superpowers? Here's a handful of things, but to give you a sense, to give you a flavor of what you can do, you can ask an element if it has a certain condition. Like if it's a checkbox, you can ask if it's checked or selected. You can ask if a button is enabled or disabled. And notice how the strings were chosen by the designers of the jQuery library to look like they're Ruby symbols. Right? JavaScript doesn't have symbols at all, but because if the Rubyistic way to do this would be to sort of declare an enumerable type that has a fixed number of values, the jQuery designers chose to sort of make it look like that. You can, on an element or a collection of elements, you can add or remove CSS classes, or you can ask whether it currently has a CSS class. So, a standard kind of trick you would use this for is if there's a particular div or panel on the screen that is supposed to represent a message to the user, and the message is trying to tell them something really bad happened, you could add a class to that div to make the message show up in red or something rather than the usual color. Or jQuery defines some pseudo classes for you to hide elements. So if you add a class called hidden, it will actually make the element temporarily go away. It's still in the DOM tree, it's just not visible on the page. So those are the kinds of things you can do. You can ask for or change the HTML or text value of the element, so you can change the actual text content. You can set specific attributes. You can make elements appear or disappear. You can fade them out. You can slide them up and down. You can animate them. All kinds of fun stuff. So all of these things are things you can do on the jQuery superpower enriched version of the element. You can't really do them on the element itself because that's kind of what jQuery is giving you. So this table is taken from the book, but the jQuery documentation is fairly easy to navigate, and it's got the complete list. I just kind of chose some of the most commonly used ones.
Alright, due to the time constraint, that will be the last video we watched today. Well, I will just quickly recap what we've watched so far and what's left out. So we started from video 2.0, where we have a brief look at the history of JavaScript. We watched 2.1. Learn about some main characters about JavaScript, and 2.2 was the basic defining variables, those basics, how to do those basic stuff in JavaScript. 2.3 we talk about is inheritance, although I would recommend avoid prototype-based inheritance as much as possible. Basically, if the project is simple enough, just don't even use that at all. And if it gets complicated, try to use something like TypeScript, JSX, or Babel, or some other things to do it using classes instead of prototype. Although it's still good to have some basic understanding about what's going on with prototype-based programming. And then last video we looked at DOM, which is basically the JavaScript API or the interface that's implemented in most of the browsers, or you could even say all of the browsers. Well, technically it's not all of the browsers, but yeah, like 99.999% of browsers will have that. And then that's the way in JavaScript can interact with the DOM element or the page element on a certain page. A quick summary for the videos that's yet to be watched. Although we won't watch it in this course, feel free to still watch it if you got the time. If you are already comfortable with JavaScript, you can probably just skip all of that. 2.5, we talk about accessibility, and you may not really feel like accessibility is something important. I personally actually had some experience with that. Basically last year, I had a major eye surgery, and during recovery for a couple of weeks, I basically had to keep my eyes closed 24/7. And then I started to realize that accessibility is actually important for people with special needs. And it doesn't even have to be too serious, even for people with color blindness. Like, how do we pick color for a web page? That's a thing to be aware of. And then if you consider people who cannot hear, cannot see, or have not necessarily 100% blind, but have difficulty in reading or stuff like that, then accessibility is something actually should be considered even during the design phase of an application. So 2.5, video 2.5 kind of give a quick intro to that, and there's actually a whole field of study if you want to dig more into that thing. Events and callbacks, basically in that video you will learn how to listen to events using jQuery and how to implement callbacks to handle the events. Ajax 2.7 talks about Ajax, basically making calls to, for example, RESTful API in the backend to dynamically change elements and data in the front end within the browser. 2.8 talks about testing. We haven't talked about TDD or test-driven development yet, so we will, if we get the time, we will actually revisit 2.8 and watch that. Just give a little peek into how to do testing in JavaScript. Although the principle is the same, it's typically a bit tricky to implement that in JavaScript compared to other languages. And then 2.9 talk about single page app, which actually is pretty popular these days. And in general, I think if a site doesn't really need stuff like SEO, then it's probably okay to just implement it as a single page app. And then generally speaking, I think a single page app offers a greater user experience if we don't consider like compatibility or users who just turn off JavaScript in their browser. And then 2.10 and 2.11 are reading materials. And then I would recommend you, if you got time to read it. And then last thing, so the book the professor mentioned in the video, which is called JavaScript, the Good Side, I believe. I would actually recommend another book instead of that one. And then that book is JavaScript Definitive Guide. Can I get a large one? Yeah, so that's this book. I've quickly browsed through the other book that the professor recommended. I mean, it's a good book, but still, I personally think this book, the JavaScript the Definitive Guide, is a better book. It touches some more detailed stuff. But again, this book has like, how many pages? I forgot. This book is it has more content, so if you are short in time, that book, then JavaScript, the good side, is still a good book to read. Otherwise, if you have enough time, I strongly recommend to read this book instead of the other one. Alright, so that will be the lecture today. I believe we will still have a lecture next Tuesday, and then the big event is coming up, so we won't have class next Thursday and the Tuesday after that. But I will announce again in the chat room. So, but unless something special happen, we should still have course as usual next Tuesday. There's no additional homework for today, so all that you need to do for this week is the homework we already assigned in Tuesday's lecture. Alright, so let's conclude then. Thank you for joining. I'll see you next week. Bye.